All right, so today we're going to talk about rational exponents. So this is going to be something that you guys might find pretty interesting. Exponents are all about how many times you're multiplying itself by itself, right? But what happens if that number is a fraction? Well, it's actually kind of an interesting math property. Basically, if you think about the denominator is usually kind of the opposite. It's usually the opposite when you're thinking of like multiplying and stuff like that, right? Well, what happens when you raise something to a fraction is it's very similar to kind of that opposite kind of action. Because what you're actually doing, instead of multiplying it by itself, twice, you're actually finding the root. This bottom number basically tells you the root that you are finding. Since it's a 2, it's a square root. This top number is your exponent. Okay? So that's what you're going to raising everything to when it's all said and done. So for example, 1, you're not going to really end up raising everything, but you need to find this as a root of 2 or just a square root, right? So to write this in radical form, we're just doing the square root of 3x. That's the same as saying 3x to the 1/2 power. And you can even check that if you wanted to. Let's do a square root, something easy. So let's say 9. Square root of 9 is 3, right? So if I do 9 and raise it to the 1 fraction button, 2, I should get 3, right? And that's exactly what I get. That is the same as saying the square root. So when you got these fractions as your exponent, it's basically just referring to a kind of root. Okay, what about this one? This one has 5 over 3. So again, 3 would be the root, 5 would be the exponent. So when I write this, it wants me to find the cube root of 6n, and that's all being raised to the 5th power. That's what it's saying. You could also write it like this. I like this form best, but another way that you could write it is the cube root of 6n to the 5th power. Okay, but I like that one best. That's what I'll probably have for all my answers, is that method. But this is also correct. Okay, let's write another one here just to make sure we got it. So 5 over 2, that means it wants a square root to the 5th power. So square root of 6v to the 5th power. Pretty easy, right? Let's look at another one. So exponential form. So this is a square root, so that means that the denominator should be a 2, right? So if I were to write this in exponential form, that means I'd have 7p to the, there's no exponent, so it'd just be 1 over 2. That would be that in exponential form. And this one, well, let's look at this one over here. So this one is a cube root to the 5th power. Okay, so cube root to the 5th power. So again, to write it in exponential form, would be 7x. Exponent goes on top, so it'd be 5 over my root, which is 3. 5 over 3. Okay. Let's go through and actually simplify some now. So this one gives me 64b to the 6 to the 1/2 power. So again, what's wanting me to do is it wants me to square root b to the 6 and 64. So square root 64 b to the 6. Okay. So when I do that, I am going to take 64, square root of that is 8, and then b to the 6. Again, it's kind of like multiplying. So it'd be like taking out a half of it, so it'd be b to the 3rd. Okay. And any others I want to go over? Let's see. Ooh. Let's do this beast down here. So this beast right here. Oh, let's see where to start. So I have b squared. Well, let's break this down first. So this is a square root of b times, and then I've got, so basically when you are, let's look at this like we're distributing. So distribute those fractions. 1/2 times 1/4 is 1/8. So that would be the 8th root. So 8th root of a to the 4th. Okay, and then 1/2 times 2 would just be b. So then to combine b and a here, that would be, it'd be like a 1 and a 1/2. So that'd be 2, be 3/2. So b to the 3/2. And then 4 and 8 would be 4/8. Would be 1/2. Doesn't seem right. A to the 1/2. That should be right. Okay. And that would be that answer right there. Hopefully. I'll double check that one later. Okay. And that's how you would do it. Again, it kind of helps to think of these as fractions. I know I broke it down to square roots first, but when you got a beast like that, work at them in fractions. That's kind of the reason why they do the fractions and stuff, because it's a little bit easier to combine and look at how things work as fractions rather than as roots.